Okay, for this video I'm trying out my new 3-axis gimbal iPhone tracking device. If it'll follow me around the room. I'm not moving very far, but the purpose of this video is not that. We'll do that later. But this thing is so neat. I just wanted to temporarily show you my gimbal tracking device for my iPhone. It really works surprisingly well. This is the first time I've used it, and I'm just demonstrating it here, taking a picture of it with my iPad. But works surprisingly well. I've been impressed with it. So I used it for the introduction of this video, and I just thought I'd share this little clip with you. Okay, we're going to go over the general design of my Van de Graaff generator. This is a 12-inch stainless steel charge collection sphere, just a gazing ball. You can get them off Amazon. Kind of expensive now though. But we found it has a positive charge relative to electrical ground. This is a flat nylon roller, no crown on it. This is an acrylic cylinder and housing here just to help guard us from the moving belt and the pulley down here not shown. This is a grounded corona brush. It's just a copper wire splayed out, but close to, but not touching the belt. That's electrical ground connected to an outside ground rod in the soil. It's just a ground rod for the house. This is similar to the bottom brush here. It's a corona brush, not touching the belt, but in electrical contact with the inside of this sphere. This is just a neoprene rubber belt. This is a nylon roller wrapped with PVC electrical tape to create a crown surface, which means higher in the middle, for belt centering. It is surface wrapped with a PTFE Teflon coated fiberglass tape so I can create a Teflon surface for contact with the inside of this belt. So that's what we've got. When you're looking at this thing, you'll know what it's all about. In my last video, I described how I made this Van de Graaff generator, and but I had it exposed. The moving belt and the pulley down here were kind of hazardous, so I restricted the video to 18 and over just for safety. So instead I've made a acrylic enclosure for it with this acrylic cylinder in this box here to help protect all the parts in there. And but it's decreased the size of the sparks a little bit, and I think I know why. But for the purpose of this video, I just wanted to find out, can we use an ordinary voltmeter that's good to 1,000 volts to check the polarity of something that could generate hundreds of thousands of volts? So we're going to give it a try, see what we come up with. Let me point out a couple of things before we get started. Of course, the neoprene rubber belt, I got a Teflon tape covered nylon pulley down here, but Teflon's a surface exposed to the neoprene belt. You see the corona brush I've got down here? It's just a stranded 12 gauge copper wire splayed out a little bit, not touching the rubber belt. And I've got that grounded. This goes out the window to a ground rod I've got in the ground. I've also got a ground connection here to this wand. Now I did have the ground connection going up inside of it, but Microsoft Copilot told me I get bigger sparks by attaching it to the outside of this. Inside up here and outside for this one. I thought, we'll see. It did seem to help a little bit, but certainly didn't hurt. So, but on the upper side here, you can see there, the corona brush is right up there. It's just like the one down there, but it's not touching, but it is making internal contact with the inside of this charge collection sphere. This is my old Craftsman voltmeter. It's supposed to get up to 1,000 volts. Right now I've got it on 2 volts. I'm going to show you what happens when we check voltage normally, like on a C-cell like that battery. Okay, I'm going to make contact with the negative side of the battery with the black lead, which is going into the common. I need a third hand to do this. You see the voltage, 1.5 volts. You'll notice there's no positive sign or negative sign there, indicating it's positive. Now look what happens if I reverse the leads. See, now you see minus 1.5. So when we check voltage up here on the Van de Graaff, if we don't see a negative sign, it's positive. This is positive. If we do see one, it means this is negative. Let's give it a try. We're going to go back to 1,000. We're not going to touch it. We don't want to blow up my voltmeter. Okay, now what I'm going to do is connect the black lead here, the common, to my ground, out my external ground. Okay, so what we're going to be doing is measuring voltage relative to ground. So I'm going to, voltmeter's on 1,000. I'm going to turn on the Van de Graaff and just bring the probe near the charge collection sphere and see what we get. Okay, you can see the voltage went up positive. Let's discharge this thing. I didn't want to touch it because that'd way exceed the voltage limit of this voltmeter. It's indicating a positive electric field there. Now you can see I've got the positive test lead here, the main voltage test lead, taped to this smaller sphere. Remember, this sphere is grounded. I've got a ground connection right over here on the external of it. So really, the voltage, any voltage we measure in that should be, shouldn't really be much because we're measuring between ground and this. Let's see what happens when we get it going. I've changed the voltmeter scale to 20 to make it a little easier to see. But watch when I bring the smaller sphere to up near the big sphere, it's mostly positive. Bounces around a little bit, mostly positive. But when I move it away rapidly, you'll see it surge negative. Like watch here. See, surge of minus 0.89. That surge of minus 0.77. Pretty interesting. Okay, I think we pretty well showed if we bring the voltmeter probe just near the charge collection sphere with the Van de Graaff running, it was indicating a positive voltage. We obviously couldn't measure several hundred thousand of this voltmeter, but definitely a positive electric field. What was interesting is when I bring this grounded 6-inch sphere with my test lead taped to it, near it, it pretty mostly bounces around a little bit, mostly positive, as you might expect. But when I move it away, it would indicate negative. And I think that's because the positive field here was pulling an excess of electrons from ground up into this sphere. And then when I move it away, it indicated a momentary excess negative charge. That's why I measured negative. That's what I think was going on. So I think it's a pretty safe bet that this is probably running with a positive charge on the sphere. And so anyway, hope you enjoyed this, got something out of it. We will be doing some other videos of this, learning some things about it. And one of my next things, I'm going to experiment with modifying this arrangement here, try to get our sparks back up to about 4 inches. But so probably what's happening there is excess charge is kind of bleeding off down around this acrylic here. Most likely that's it. So anyway, hope you enjoyed this, and if you did, please like the video and subscribe, and make sure you look for our upcoming videos and check out our older videos too. We really appreciate it. Thanks for watching.